Okay, so hello everyone. The very last video we mentioned a question called round trip, and I told you that to comment on that, and I will also make a solution video for that. So basically, we had discussed how do we detect cycle. So cycle detection was discussed, and we discussed it using BFS. We can also do it using DFS. First, I'll show you that, and then I'll show you that how will you print the cycle. So cycle printing is the main part of the problem. So as I'd already discussed in the last video, it's better that you watch the last video because that has cycle detection using BFS. So the question is that you have n cities and you have m roads, and uh, your task is to just say that can you start at a particular city, like at any node. Let's say you're starting, so can you start at a particular node and find two nodes in between, like two or more nodes in between, and end at that same node, right? So you can have two nodes in between, you can have three, four, completely up to you, right? Okay, so then how do we do it? So let's say we use DFS. So I'll just show you the example. Like let's say this is my graph. This is my graph, and you can clearly see there's a cycle, right? So I'll start DFS from my source and also note parents, right? I'll keep noting, like in the argument of the function I'll have int s and int p. So I'll have my source and I'll have my parent, right? So let me start from 1. So from 1 my DFS goes to 2, then it goes to 3, right? Because we are maintaining visited array and all of these are unvisited, so there's no problem, right? So when it goes to 3, then it checks that 2 is one of the nodes and 5 is another node. Now 2 is a parent, right? So there's no problem. And keep in mind that we will always make a parent array here, right? So like we are having int s and int p now. So what we will do is we will always mention in that parent array that your parent of u, or s in this case, parent of s is equal to p, right? So that we can track back, because when we'll detect a cycle like that, I'll show you how will that happen. So let's say we go to 3, so 2 is a parent, so no problem. 5 is unvisited, so then DFS of 5, right? DFS of 5 comma 3 happens, right? Then it goes to 5, C is 3 is a parent, and then 4. So then it goes to 4, 4 is unvisited, so performs a DFS on 4, right? Now when it goes to 4, then it says 5 is unvisited, sorry, 5 is a parent, so no issue. But then it goes to 1 and sees that 1 is already visited and it's not the parent. So here there's a main problem, right? So 1 is visited, it is visited and not parent, right? Both of the conditions are true, so therefore we have our answer is true, right? So we could have just returned true if we were supposed to detect a DFS, if you're supposed to detect a cycle, but here there's something else, right? So what we will do is the vertex where we are able to detect a cycle, right? Like in this case it is this vertex. So if that condition is true, we will note that which is our ending vertex. So in this case our ending vertex is 4, right? And the vertex that, like, for the particular vertex in which this condition was satisfied, we will take that as a starting vertex, which in this case is 1, right? So what is our mission now, what is our aim now? It is basically to track back this path, that कि हम यार 4 से start करते हैं, then हम 5 से जाते हैं, 3 2 1. Basically you can start from 1 and go through this path and return at 1, right? So we have to print this path, that is the main concern. So if you have noted the algorithm till now, you will get that we have already flushed the parents, right? We have already noted the parents in a parent array. So like when we started with this, right, so we have noted that parent of 1 is -1, parent of 2 is 1. Similarly, at the end when we ran it on 4, so we noted that parent of 4 is 5, right? So then what we have is, we have our ending vertex now. We have our ending vertex, which is our ending vertex, it is 4. Ending vertex is 4, starting vertex is 1, right? So if our ending vertex is 4 and starting vertex is 1, we will run a while loop, right? And the while loop will look somewhat like this, that while ending vertex is not equal to starting vertex, right, till that time we will basically keep tracking back. How to track back? So we will basically print parent of my ending vertex. So you can very well understand that if I start at 4, so parent of ending vertex is 5, right? So it will go to 5, right? Then now see, 5 is again not equal to sv. Okay, so what should I do in the next line? Okay, so I should also change my ev, and ev will be now parent of ev, which is basically 5. So then it will go to 5, then it will go to 3, and none of them are equal to 1, so then it will go to 2, and then it will go to 1. So now we have the cycle, that the cycle is nothing but 4 5 3 2 1, right? And what is the starting vertex? Starting vertex is 1, ending vertex is 4, right? So we can just print it reverse, so it is 1 2 3 5 4, and then at the end again 1. So this is your answer, and hopefully you have understood that how we will do it using DFS and how to print it. Basically we give a parent array and nothing special, it's a very basic problem. Thank you. You can write your doubts.